All right, everyone, it's me again, Mrs. Fisher. Today is Unit 1, Day 5. And we are going to talk about 4 more log rules. I can feel the excitement through my computer screen. Okay, so we talked about the basic properties of logarithms. We talked about how to use the definition of a logarithm, but there are a few more rules that we're going to talk about before we can actually use logs to help us solve problems. And these, again, are all things we talked about in Math 3. So here are the 3 rules. We have what is called the product rule. Okay, the product rule basically says log base b of m times n. So you've got a product. It says that you can take that product and break it up into 2 separate logarithms. Okay, and these rules work both ways. So it also means if you have log base b of m plus log base b of n, you can put them together into a product. So they go both ways. Yeah, the quotient rule, which says if you have log base b of m divided by n, that you get log base b of m minus log base b of n. And we did this whole investigation in Math 3 that used numbers to prove why these work. And we used our logical arithmetic with all those numbers to kind of prove those. I started to write property. These could all be called properties if you wanted instead of rules. The power rule, the last one, says if you have log base b of a number raised to a power, that you can rewrite that as the power times log base b of the number. We proved this one as well in our little investigation using some numbers. And the product rule helped us to prove that. All right, but if you want me to prove those with you, I'll be happy to go over them with you again. Just not in this video. All right, we are going to use these properties to do some basic problems that kind of seem silly because all we're doing today is becoming familiar with the rules. We're not going to actually do anything with them, so they seem silly. But we want you to practice the rules to become better at using the rules so that when we're actually solving some problems with them, we will be more proficient at these rules, okay? So for right now, the 2 types of things that we're going to be doing, the first type is going to be expanding. Expanding means take this apart as far as you can, okay? So take the problem apart. Using all the rules as far as possible. Okay, and again, the problems seem kind of silly, but we're just practicing how the rules work at this point. So, for example, if I give you something like the log of xy cubed, and I ask you to expand. Right now, everything's all put together. I have one log, and I have x times y to the third. So my argument is all there together after one logarithm. Expanding means I want to take it apart and have multiple logs, multiple arguments. Okay, so I want this to all come apart. So the way we are going to do that is to use our rules at the top. So right now I have a product, x times y, and I have a power because I have this y to the third. So the first thing I'm going to do is use the product rule to pull apart the product. So we are going to do log of x. The product rule says to take apart a product. I am going to use addition. So I'm going to have log x plus log y to the third. Now notice my initial problem is a common log. It's understood base 10. So that would be the b that you see in the product rule. I don't have to write that down. Because with a common log, you don't have to write that down. Now, according to what it says for expanding, it says take the problem apart using all the rules as far as possible. So I've done the product rule. I still have a power in the problem, so I still need to use the power rule because I need to use the rules as far as possible. So I'm not done yet. So log x, I can't do anything else with. There's no other rule I can use there. But for the log y cubed, I can use the power rule to bring this power down in front. Because that's what the power rule is basically displaying. The p comes down in front of the logarithm. All right, so then I'm going to have 3 log y. All right, so that is fully expanded. Let's try another one. All right, let's do natural log of x squared and then cube root of p all over y. And you might be saying, why? Why this problem? All right, the very first thing I would do is I would take this lovely guy here and change it to a fraction exponent. And the reason I would do that is because we don't have a rule that says a radical rule. We have a rule that says it's a power rule. So I'm going to change this to a power so that I can use the rules that way. So ln x squared, a cube root is the same thing as a 1/3 exponent and divided by y. All right. So then I'm going to use the product rule and the quotient rule to take my argument apart as far as possible. So I'm going to take all of this apart. Then I'm going to deal with the powers last. So this is going to be ln. The first part of my argument is this guy. So x squared is being multiplied by, so I'm going to do add, p to the 1/3. And if, geez, I messed up. So ln of p to the 1/3. Okay, and because that's all grouped together, those two are in a product together on top. If you have any questions about what you should do about grouping, you can go ahead and put that in parentheses just to be on the safe side. But all of that's being divided by y. So this is a quotient right here with this division. So I'm going to go ahead and put a minus because our quotient rule says to split up a quotient, you use subtraction. So I'm going to put minus, and then ln of y. Okay, in reality, you don't need those parentheses in this one, but like I said, if you're ever in doubt about whether or not you need them, it's a good idea to go ahead and just use them. Now, we have not used all the rules as far as possible because we still have this power and this power. So we're going to go ahead and use the power property to bring the powers down in front. Okay, so we are going to get 2 ln x plus 1/3 ln p minus ln y. So that would be fully expanded. All right. The next type of problem would be to combine, or sometimes you will see condense, same kind of thing. But combining problems means you want to put them together as far as you can, using the 3 rules. As far as possible. Okay, again, this is just practicing using those rules. We're not doing anything with the problem. Once we've used the 3 rules, we're just trying to kind of go as far as possible. All right, so it works kind of backwards from the ones that we just did. In the ones that we just did, I was doing the power property last. So in these, we're going to use the power property first. So if you have this example, 3 ln x minus 1/2 ln y plus 5 ln z. So when you are putting together, you are going to do the powers first. So all of these have numbers in front, become powers of the argument. Okay, so this is going to become ln of x cubed minus ln of y to the 1/2 plus ln of z to the 5th. And then from there, you just work left to right. So I'm going to look at these first 2. And they've got a subtraction sign, so I'm going to use the quotient. So ln of x cubed divided by y to the 1/2 power. So remember that is a square root. So if you want to, you can write it as square root y, or you can leave it as y to the 1/2. It really does not matter. But then you have plus ln of z to the 5th. So now when you put these 2 together, with the plus, that means you multiply. So if we are doing ln of x cubed over square root y, and then times z to the 5th, typically where would we put that z to the 5th? Remember, this is like an over 1. So you would normally not leave your answer like we have it here. We would go ahead and put that all together in one fraction. So it'd be ln of x cubed z to the 5th all over the square root of y. So you can leave your answer like that. All right, so that's that. So that's how combining works. You're just working backwards from the expanding. All right, the last rule that we need to learn about before we can actually go solve some problems, which we will do next class, is change of base. So change of base is when you have a base, like log base b of a number. The change of base formula lets you change this to a common log or a natural log. Now, it lets you basically compare logs of different bases if you want. You could actually change this to any base. It doesn't have to be common log or natural log. It can be any log at all. It could be log base 5. It could be log base 7. It doesn't really matter. But typically it's used for common logs and natural logs because that's the log button that's on your calculator. But anyway, it says that if you have log base b of a number, that you can evaluate that by using your log button on the calculator of the argument n divided by the log of the base number. And when you write it like that, remember this is base 10 because I didn't put a number in there. You could also, instead of using a common log, you could use ln. So natural log of n over natural log of b. So I know as a kid, I always forgot which number went on top and which one went on the bottom, whether n went on top or b went on the bottom, vice versa. And I don't know why that was hard. Base goes on bottom. I should have been able to remember that. But base goes on the bottom. This number is always written in a small font. This is always in a big font. So we sometimes call this Biggie Smalls because it's Biggie first and then Smalls is last. So any way you all want to remember it, it's fine. But base goes on the bottom. If you have an old calculator, you're going to have to know how to use this formula because it's the only way that you're going to be able to solve some problems. So for example, if I ask you to evaluate log base 5 of 2. In your calculator, if you have an old calculator, you have to use change of base formula. You would have to do log of 2 divided by log of 5. And you would just type that in your calculator. If you have a newer calculator, then your newer calculator would let you evaluate that pretty nicely if you go to the math menu. And I believe it's option A, which says log base. This is all stuff we went over last year in Math 3. But in log base, it lets you type in, just like you see it, log base 5 of 2. But you are required to know what the change of base formula is, whether you've got a new calculator or an old calculator. You do need to know what that formula is. All right, that's all for today. Pretty short, sweet, to the point. Hope you enjoyed the lesson. And we'll see you next time.